Hi guys, this is Miss Raina. I'm here to help you figure out how in the world to solve a physics problem. So the first and the hardest thing is always how in the world to start. And I want you guys to be following along on your guided notes page and filling in these blanks. You always start by stating what we call the knowns, and that's why your box says K for knowns. So you guys have this same problem. You're going to have to scratch out how far and you're going to have to fill in how long. That's my fault. I didn't make that edit before I gave you the paper. Um, so let's figure out what we know here. And the easiest thing to do is look for numbers with units. So circle those on your actual problem. And when you write them down, you're going to make sure you label them with variables and make sure to include units. So this says 25 meters per second. The units tell me that that's a velocity. This one here says 15 meters away, and the units tell me that that's a distance. So sometimes it helps to draw a picture, and you would do that in this first step when you're trying to sort out your knowns. On your crisscross, you make sure that you always write down the variable and you always indicate the unit. So I like to do that first and then draw the crisscross, and that way everything fits in nicely. Today, you're just going to draw it on the crisscross that I already made for you. Okay, step 2, fill in this blank. This is where you state the unknowns. That's why on your crisscross there's a little U over here for unknowns. What does that mean? Well, basically, what are you trying to solve for? So look for the question mark. And they're asking you, how long does it travel? And here's the challenging part, because you have to figure out, well, what am I supposed to solve for? They want to know how long does it travel? And so that's asking you for an amount of time. And so in my problem, I circle it and label it there, but whatever you do, make sure you write it in your crisscross, your variable and your unit. You're looking for time in seconds. Next thing we have to do, it looks kind of crazy and daunting because you're going to have an equation sheet like this and you're going to have to pick the right one. It's not hard. If you know your ABCs, you're going to use your known and your unknown variables. That means the label, the letter out in front. So I've got a V, a D, and a T. Find me the equation with the V, the D, and the T. So if you want to pause the video and get it going when you're ready and you found the one you want, if you, they're the letters we want, the V, the D, and the T. If you identify this one right here, velocity equals distance over time, as the equation with V, D, and T, then you got it. You're going to write it down here in the box labeled E for equation. So write it down in the equation box. Next, this is the part that everybody loves and hates because, yes, you do need to show your work, all right? So all that time that we spent practicing algebra, here's where it comes in handy. You're going to isolate the unknown. What's the unknown? Hey, I already wrote it down right here. It's not going to be hard to figure out what to isolate. So let me just go ahead and do the algebra steps. I'm going to multiply each side by t, divide each side by v. Finally, I get my t isolated. And it looks like I'm going to have to do d divided by v. All right, now I can go ahead and put in numbers and units. And the trap that everybody falls in, they see that they've got 25 meters per second and 15 meters, and so they're trying to figure out immediately, well, I'm just going to multiply those, right? No, I'm just going to divide them. No, I got to divide one by the other. Look, don't mess with that. Go through these steps. If you do the steps right, first of all, you get the credit. But second of all, they keep you from making mistakes like that, and they keep you from getting confused about what to do with these numbers and when. So now is the step where we can finally put in the numbers, and I know exactly what to do with them. I'm going to take 15 divided by 25. I make sure I have the units in there so I can cancel out the units that don't belong. Seconds under a division bar are actually going to come out to the top. That works for me. I'm looking for time in seconds. So I take 15 divided by 25, I get 0.6. I'm supposed to apply significant figure rules, and so if you don't remember those from last year in chemistry, we can talk about those in tutoring time. Lastly, I make sure I included my units and I box my answer for clarity so I get all the credit that I deserve. All right, if you have any questions about this process so far, I want you to write them down and we'll discuss them in class tomorrow. So how did we know what to label those things? Anything that talks about speed, you label it v, velocity. Anything that talks about distance, displacement, change in position, label that D. That's going to be in meters. And obviously anything for time gets a label of a lowercase t. A big T means temperature later, so make sure these are all lowercase. All right, so take a minute right now and pause the video so you can identify on all of those boxes which unit goes with which symbol. So I kind of gave it away a little bit earlier, but if we see symbol of meters in the question in one of the knowns, then we're going to identify that as a distance. Kilometers per hour, look, it's a rate. That tells me it's a speed. Miles, you guys know that that means distance away. Seconds, that's easy, that means time. Meters per second isn't so common in normal use for Americans, but this is definitely what we're going to be using in physics class. So that's going to denote speed. Kilometers, same thing. Americans don't necessarily get used to using metric terms to describe distance, but we need to be able to do metric as well as standard. Hours is definitely a time. Miles per hour is a speed unit we're used to. Centimeters, we're going to use that to denote distance. Every time we get something that is not an SI unit, we're going to have to convert it, guys. So if you get something in meters, seconds, or meters per second, you're fine. Otherwise, all the rest of these, you need to change them to SI units if you get them during a problem. All right, here is the first equation that we're going to use. This is the only equation that we're going to use in your practice problems tomorrow. You will have a poster contest, so we will be solving problems and you will be in your teams. Be ready. There will definitely be prizes at the end, all right? So again, write down any and all questions you have so we make sure we take care of them before you're having to use them on your poster contest. Thank you everybody for watching and listening, and we'll see you in class tomorrow. Bye.